So we're going to continue on with curve sketching. And so before now, what we've had has been, so the first two examples were pretty easy. They were, r is equal to a constant, theta is equal to a constant. And in the last example, I sketched a graph by, plotting points. For this one, so the example is to sketch r is equal to 1 plus sine theta. You could make a table of points here, but, another thing you could do is you could draw what this function looks like in the r theta plane. So when I'm reading off those points, r and theta, I could just as well, draw this graph and then read points from this graph. So what I'm doing here is I'm using, in the r theta plane, I'm going to draw the graph of 1 plus sine theta, which is, sine theta shifted upward 1. It's going to look something like this. So we'll get one period of it. So the values here then, so at pi over 2, I reach my maximum because sine of pi over 2 is 1. I go back to 1 at pi. At 0, I'm at 3 pi over 2. And at pi, I'm back at 1. So I'm just, I'm thinking, when I plug in, I'm identifying these different points here, is what I'm doing. And I'm doing that by, thinking about what values this takes on, the 1 plus sine theta. And from this, I can, look at this and figure out what's going to happen when I draw this graph in the xy plane. So remember, these just give me values of r and theta. Okay, so at theta equals 0, I'm on the x-axis. So for theta equals 0, let's do red, which will make a little more sense in a second, maybe. I don't know if it's really a joke, but it's mildly entertaining, hopefully. Okay, so we're going to do this in the xy plane now. Okay, so at theta equals 0, I'm on the x-axis. Theta equals 0 is, I don't have I have 0 angle. So for theta equals 0, I have a radius of 1 here. And what you should notice now is I'm going to go from, at pi over 2 here, which is the y-axis, I'm going to be now at 2. And what you should notice is the radius is always increasing between, goes between 1 and 2 as, this thing goes from 0 to pi over 2. So I'm going to connect these two lines, but I need to do it in a way that isn't, on a circle. It's, a circle, the radius is always increasing. So I'm going to draw something like that. And so maybe depending on my scale, it's not going to come out how it would look if you did on a calculator. That's fine. I'm, not the greatest artist here. Okay, so from 0 to pi over 2, I go from radius 1 to radius 2. From pi over 2 to pi, so pi is the negative x-axis, I'm going to be at negative 1 there. So I'm going to be at y equals 1. So I'm going to be at a radius. Yeah, sorry. No, that's good. So at the angle pi, I'm going to have the radius negative 1. I'm going to have the radius 1, sorry. And that's going to look like this. So that point there is a distance 1 from the origin. So now as I go from pi over 2 to pi, my radius distance from the origin needs to decrease. And that's what happens, as I draw this arc here. This distance is bigger than this distance. So the distance is decreasing there. Then I'm going to go from pi to 3 pi over 2. 3 pi over 2 is the negative y-axis that I just drew an arrow to and I'm about to erase. So when I go from pi to 3 pi over 2, my radius is still decreasing, so the distance from the origin is decreasing until I get to the negative y-axis, the angle 3 pi over 2, where I'm at the origin. And then from 3 pi over 2 to pi, my radius begins increasing again. And it's going to look something like that. So it should be, symmetric on this side. And so this is what the graph looks like. So this graph here, r equals 1 sine theta, 1 plus sine theta. This has a name, it's the cardioid. It looks like a heart if you draw it correctly, I guess. I'm, again, no artist here. So let's do another example. So we're going to do r is equal to cosine of 2 theta. Okay, so we're going to sketch this. And so, I'm doing all this because, as I'm doing these examples, they're already worked out. I'm, going through explaining them more. The values that I let this thing go over, you have to figure out yourself. I don't know them off the top of my head. I know them because as if I were working out this problem, I would see that, as I was drawing a curve, it might not be finished, so I need to compute more values of r and theta there. So r is equal to cosine of 2 theta. So what this is going to be, if I go from 0 to 2 pi, let's call this 1 and negative 1. What this is going to look like is, so let's do pi over 4, pi over 2, 3 pi over 4, pi, let's see, 5 pi over 4, and then we're going to do 7 pi over 4, so just, yeah, so that'll work. Okay, so those will be my points. So then, if you plot some of these, so cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi, so pi over 2 meant negative 1, 3 pi over 4, pi, 5 pi over 4, 7 pi over 4, sorry, 3 pi over 2, hang on. I missed one. That explains that. So we need 3 pi over 2, 7 pi over 4. Sorry. 3 pi over 2, I'm going to be at negative 1, 0, 1 again. And so this will give me the cosine. Really shaky cosine here. Okay, so let's try and draw this. And again, so you don't have to argue with me about this being, difficult to do. I know it's, not easy. It is a skill that you need to learn eventually, though. It helps you with other coordinate systems. There are more complicated coordinate systems than this, especially when you work in higher dimensions. So anyway, so let's do some of these. So at theta equals 0, I'm at the radius 1. So that's going to be on the x-axis, the distance 1 here. At theta equals pi over 4, I'm at 0. So I go from here to here. And my radius, my distance from the origin is decreasing when that happens. So that's going to look like that. Okay, so when I go from pi over 4 to pi over 2 now, pi over 2, I'm at negative 1 here. So at the angle pi over 2, my radius is negative 1. So I'm going to actually be down here, it looks like. So actually, let me draw this in a different color. So that'll be my first one. My second one looks like I'm going to go from here to here, and it should be the same distance. I really do not like graphing, if you haven't figured that out. Okay, so anyway, let me just reiterate what I'm saying. From pi over 4 to pi over 2, I go from 0 to, so my angle at pi over 2, or sorry, my radius at pi over 2 is negative 1. So instead of being on the positive x-axis, or positive y-axis, I'm going to be on the negative y-axis. So I'm going to look something like that. Angle pi over 2 to 3 pi over 4, I go from radius negative 1 to 0. So it's going to look like that I just drew. So now I have, this is going to end up looking like a flower. This is a petal of a flower. And now I just keep going. From 3 pi over 4, I'm at the origin. At the angle pi, which is the negative y-axis, I'm at 1. So my next point here is at 1. Let me switch back to black to draw -1 here. And so at going from 3 pi over 4 to pi, I go from a radius of 0 to 1. So that'll look like that. From pi to 5 pi over 4. So let me draw in some of these angles just so you can see what I'm doing here. This is pi over 4. This one is 3 pi over 4. 5 pi over 4. 7 pi over 4. And this is 0 pi over 2 pi 3 pi over 2. And then this will be 0 or 2 pi. So maybe that helps a little bit to see what I'm saying here. Anyway, so I was at I was at pi, and now I'm going to 5 pi over 4. So as I go to the angle 5 pi over 4, I need to go back to the origin. So this is going to look like this, except I'm doing it in blue. It's going to look like that. So as I go from 5 pi over 4 to 3 pi over 2, so in this angle region, I'm going to go from 0 to -1. So that is actually going to be this one, because so normally I would be on 3 pi over 2, but because I have a negative radius, I'm going to jump up, I'm going to go on the opposite direction to that one. So from 3 pi over 2 to 7 pi over 4, I go back to the origin. It's going to look like that. From 7 pi over 4, okay. 3 pi over 2 to 7 pi over 4. Hang on. So did I screw up somewhere? So going from, so what was the one I did before that? 5 pi over 4, I was at 0. Then I go to 3 pi over 2, which is at -1. So I'm up there. 3 pi over 2 to 7 pi over 4. Oh, okay, I see what's going on. Yeah, 3 pi over 2, yeah. So that was right. And then, okay, from 7 pi over 4 to 2 pi. Yeah, okay, I see what I was doing. I'm going to go along that one again. Sorry, yeah. So again, if you haven't figured it out, this is really tricky. You have to do a bunch of these before they start making sense. Even I get tripped up occasionally. But, again, what I'm doing is I'm looking at this graph, and I know a lot of you are hearing me do this and thinking I'm insane. It is, this is how you do it, though, without a calculator. And again, you're more than welcome to, if you want, just pick points, draw those points. I'm, thinking about it in a calculus kind of way. Radii are decreasing or increasing, things like that. Okay, so I'm going to stop there. Obviously, again, this was probably, if this is your first time seeing it, this looks insane. You'll do a couple examples, you'll get kind of used to it, you'll see it on your third exam, and then hopefully you'll have it down by then. But I'm going to stop this video here and we'll continue on.